A substation is part of an electrical generation, transmission, and distribution system. Substations transform voltage from high to low or vice versa. Substations may also perform any of several other important functions. Electric power may flow through several substations between generating plant and consumer, and its voltage may change in several steps. Substations generally have switching, protection and control equipment, and transformers. In a large substation, circuit breakers are used to interrupt any short circuits or overload currents that may occur on the network. Substations themselves do not usually have generators, although a power plant may have a substation nearby. Other devices, such as capacitors and voltage regulators, may also be located at a substation. Where a substation has a metallic fence, it must be properly grounded to protect people from high voltages that may occur during a fault in the network. Currents flowing in the Earth's surface during a fault can cause metal objects to have a significantly different voltage than the ground under a person's feet. This touch potential presents a hazard of electrocution. A switch is an electrical component that can break an electrical circuit, interrupting the current or diverting it from one conductor to another. Switches may be operated by process variables such as pressure, temperature, flow, current, voltage, and force. These variables can act as sensors in a process and be used to automatically control a system. An example of control equipment is a circuit breaker. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by overload or short circuit. Its basic function is to detect a fault condition and, by interrupting continuity, to immediately discontinue electrical flow. An example of protection equipment is a fuse. A fuse is a type of low-resistance resistor that acts as a sacrificial device to provide overcurrent protection of either the load or source circuit. A fuse interrupts excessive current so that further damage by overheating or fire is prevented. A digital protective relay uses a microprocessor to analyze power system voltages and currents for the purpose of detection of faults in an electric power system. The relay is capable of applying advanced logic. It's capable of analyzing whether the relay should trip or restrain from tripping based on current or voltage magnitude, parameters set by the user, relay contact inputs, and in some applications, the timing and order of event sequences. A transformer is a device that transfers electrical energy from one circuit to another through inductively coupled conductors, the transformer's coils. A varying current in the first or primary winding creates a varying magnetic flux in the transformer's core, and thus a varying magnetic field through the secondary winding. This varying magnetic field induces a varying electromotive force or voltage in the secondary winding. This effect is called inductive coupling. Capacitors have many uses in electronic circuits, such as DC blocking, filtering, and RC time constants. Their primary use in the electric power transmission systems is for power factor correction. Capacitors are a passive two-lead terminal device that store energy in the form of an electrostatic field. Capacitive loads will cause a phase shift between the voltage and current, where current will lead voltage. Inductive loads, such as motors, transformers, inductors, and wire, also cause a phase shift between the voltage and current. Inductive loads store energy in the form of magnetic lines of flux. The phase shift caused by an inductive load is opposite of that of a capacitive load, where the voltage will lead the current. Capacitor banks are used to correct the phase shift caused by the inductive nature of the transmission system and the loads. Power is the product of current times voltage. As the power leaves a power generation plant, the voltage and current are in phase. As the power is transmitted through the transmission and distribution grid to the loads, there are significant losses of power due to phase shift. Power factor is the cosine of the phase shift between voltage and current, or the dividend of real power divided by apparent power. Capacitor banks are located throughout the grid to correct for these phase shifts and improve the efficiency of the grid. The goal is to obtain a power factor of 1, known as unity. When the grid is at unity, all of the power being created is being used as efficiently as possible. A voltage regulator is an electrical regulator designed to automatically maintain a constant voltage level. Voltage regulators may be installed at a substation or along distribution lines so that all customers receive steady voltage independent of how much power is drawn from the line. Ground is the reference point in an electrical circuit from which other voltages are measured, or is a common return path for electric current, or a direct physical connection to the earth. In an electrical circuit, exposed metal parts are connected to ground to prevent contact with a dangerous voltage if electrical insulation fails. Connections to ground limit the buildup of static electricity when repairing electronic devices.